In this video, we're going to talk about how to find the confidence interval of a population proportion. So here is an example problem. Number 1, 800 randomly selected college students at University XYZ were asked if they own a laptop. So out of the 800, 584 responded yes to the survey. Part A, can we approximate the binomial distribution with a normal distribution? Now keep in mind why this is a binomial distribution, because there's either two options. When a person is asked a question, it's either yes, they own a laptop, or no, they don't own it. Now, can we approximate this distribution with a normal distribution? There's a formula that you could use that's a good indication if you can approximate it or not. It's NP times 1 minus P. If that's equal to or greater than 10, then the binomial distribution is a good approximation of the normal distribution. But let's write down what we know. We know the sample size is 800. That's how many people were surveyed. We know the number of successes, which is X, that's 584. 584 individuals responded yes to the survey. Now, P is the population proportion. We don't know P. We don't know the exact proportion of all of the students at University XYZ if they own a laptop or not. We don't know if the true proportion is 60%, 70%, or 65%. We don't know. However, we can estimate the population proportion with a sample proportion. P is the population proportion, and P hat, sometimes referred to as P prime, this is the sample proportion. P prime is equal to X divided by N. So that's going to be 584 divided by 800. Which turns out to be 0.73. So about 73% of people responded yes to the survey. So now that we have P hat or P prime, we can now determine if this distribution will approximate a normal distribution. So now let's suggest the formula. So instead of P, we're going to write P hat. So N is 800, P hat is 0.73, and then it's 1 minus P hat. Now let's see if that's greater than 10. So 800 times 0.73 times 0.27, that's going to be 157.68. And so that is certainly greater than 10. So this distribution can be approximated to a normal distribution. Now let's move on to part B. Construct a 95% confidence interval to estimate the true population proportion of students at University XYZ who own laptops and determine the margin of error. Now you could have 10,000 students at this university. You don't want to ask all 10,000 students if they own a laptop. So if you ask a small amount and get the proportion for that, you could use that to estimate the true proportion of all students at this university who own a laptop. And so we're going to estimate it with a 95% confidence interval. But what's our first step here? What should we do? First, we need to calculate Q hat. P hat represents the proportion for the number of successes. Q hat represents the proportion for the number of failures. Q hat is 1 minus P hat. So that's 1 minus 0.73, which is 0.27. So this tells us that 73% of the individuals in our sample responded yes to the survey. This tells us that 27% responded no. So those two numbers always have to add up to 1. Now once we have Q hat, our next step is to determine the margin of error, or the error bound for the population. Once we have that, we can construct the confidence interval. So the error bound for the population is equal to the z-score times the square root of p hat q hat divided by n. Now we have p hat, q hat, and n, but we don't have the value of z. However, we could find the value of z from this number, the fact that we're trying to create a 95% confidence interval. So let's draw a picture. Let's say this is our normal distribution, and our z-score that we're looking for will be there. We need to determine the area of the shaded region. And there's a formula that you could use to calculate the area to the left that will correspond to the z-score that we need. And here it is. It's 1 plus the confidence level divided by 2. The confidence level is 0.95, since we're dealing with a 95% confidence level. So we have 1.95 divided by 2, and so the area to the left is 0.975. Let me explain how that works. Here's another way in which you can get the answer. So let's say this is the true proportion, which is going to be right in the middle. And here is our positive z-value and our negative z-value. Since we're dealing with a 95% confidence level, 95% of the area is going to be between negative z and positive z. So the other 5% is on the left side and the right side. So that means that 2.5% have to be on the left and 2.5% have to be on the right, so that it adds up to 1. Now we want all of the area up to positive z. So it's the sum of these two numbers, which will give us 0.975. But if you don't want to draw a picture, if you simply want to use a formula, this will give you the area that you need to look up in the z table. So now that we have the area from the left, you want to get your positive z-score table to find the z-score that corresponds to this number. And the z-score that you're looking for is going to be 1.96. And I'm going to show you how you can get that. So here is the positive z-score table. And we need to locate an area of 0.975 on this table. So let's go ahead and find it. And here it is. Now we need to locate the row that it comes from. So that row has a value of 1.9, and the column as well, which has a value of 0.06. So we need to add those two numbers. So an area to the left of 0.975 corresponds to a z-score of 1.9 plus 0.06, which is 1.96. So that's how you could use the positive z-score table to find the z-score if you know the area, which you can calculate given the confidence level. So now that we have the z-value, let's plug it all in to this formula. So instead of writing EBP, I'm just going to write E for the margin of error. So our z-value is 1.96, p hat is 0.73, q hat 0.27, and the sample size is 800. So go ahead and plug this into your calculator. So 0.73 times 0.27 divided by 800, that's 2.46375 times 10 to the minus 4. If you take the square root of that result and then multiply it by 1.96, you should get a margin of error of 0.0307648. I'm going to round that to 308. So that's the first half of part B. So now we need to construct the confidence interval. So here's what we can do to get it. It's going to be our sample proportion minus the error. That's going to give us our minimum value. And then the sample proportion plus the error. that's going to give us the maximum value of the confidence interval. Keep in mind, the confidence interval is a range in which we believe the true proportion to be located in with a certain probability. So this is going to be 0.73 minus 0.0308. And then to get the max value is going to be 0.73 plus 0.0308. So the minimum value is 0.6992, and the maximum value is going to be 0.7608. So this right here is our 95% confidence interval. We're 95% confident that the true population proportion is going to be somewhere between 0.6992 and 0.7608. Now let's move on to part C. What sample size is needed to estimate the true proportion with a 2% margin of error at a 90% confidence level? Go ahead and try that problem. Now, the sample proportion and Q hat, they're going to be the same because we're still dealing with the same type of problem. But notice that the margin of error is different and the confidence level. The margin of error is 2%. If you divide that by 100, we can get the decimal value, which is going to be 0.02. And the confidence level is 90% or 0.90. Our goal is to determine the sample size, that is, the new n value. So n is no longer 800 for part C. So what we need to do is adjust this equation. So let's replace EBP with E just to make things simpler. Now the first thing we're going to do is we're going to square both sides of this equation. We need to get n by itself. Once you square the square root and the square will cancel each other out, giving us what's inside. So we have E squared is equal to Z squared times P hat Q hat over n. Now our next step is to multiply both sides by n. So we have n times E squared, which equals Z squared times P hat times Q hat. To get n by itself, you need to divide both sides by E squared. So then we have this formula. N is going to be Z squared times P hat Q hat all divided by E squared. Z, in this example, well, we need to find Z. So first, let's find the area to the left using this formula, 1 plus the confidence level divided by 2. So the confidence level is 0.9. So this becomes 1.9 divided by 2. So the area to the left is 0.95. So using that table that we used earlier, we're going to get the z-score that corresponds to this area. So now let's go back to the positive z-score table. We need to locate an area of 0.95. So notice that 0.95 is between these two numbers, between 0.9495 and 0.9505. So to get an area of 0.95, we got to average those values. Let's find the z-score that corresponds to each number. So here, this is 1.64. And for the other one, I'm going to put in green. It's going to be 1.65. So if we average these two numbers, this will give us a z-score of 1.645. And so that's the z-score that we want to use, given an area of 0.95 to the left. So let's write it here. So now we have everything that we need to calculate the sample size. So z is 1.645. Don't forget to square it. Now p hat, that's 0.73. Q hat is 0.27, and E, the error, is 0.02. Don't forget to square that as well. So go ahead and type this in. 1.645 squared times 0.73 times 0.27 divided by 0.02 squared. So you should get an n value of 1333.39. Now, if you have a decimal number, make sure to round up. Even though this rounds to 1333, just to get a minimum margin of error of 2%, we want to round up. So we're going to say the sample size is 1334. This is the answer for part C. So that's it for this problem. For the sake of practice, go ahead and try this problem. It's very similar to the last one. So using the formulas that you've seen in the last problem, go ahead and solve this one. Feel free to pause the video and work on it in the meantime. When you're done, play the video to see if you have the right answer. So let's begin. Number 2. 500 residents in town ABC were asked if they own a car. Of the 500 surveyed, 405 responded yes. Part A. Construct a 99% confidence interval to estimate the true population proportion of residents who own a car in town ABC. So let's write down what we know. The sample size is 500. X is 405. That's the number of successes. And we need to calculate P hat and Q hat. So P hat is going to be X over N. It's the proportion of successes of the sample. So this is going to be 405 divided by 500. And so that's going to be 0.81. So 81% of individuals out of those surveyed responded yes. So now we can calculate Q hat. It's 1 minus P hat. So that's 1 minus 0.81, which is going to be 0.19. Our next step is to determine the margin of error. So it's going to be Z times the square root of P hat, Q hat, divided by the sample size. But we need to determine Z. So let's calculate the area under the curve to the left. So that's going to be 1 plus the confidence level divided by 2. The confidence level is 99%. So as a decimal, that's going to be 0.99. So we have 1.99 divided by 2, which gives us an area of 0.995. Now, using the z-score table that we used in the last problem, this will give you a z value of 2.575. It's in between 2.57 and 2.58. So if you average those two z-scores, you get 2.575. So now let's calculate the margin of error. So let's plug in z and everything else. P hat is 0.81, Q hat 0.19, divided by the sample size of 500. So 0.81 times 0.19 divided by 500, and if you take the square root of that, that's 0.01754, and then multiply that by 2.575. So you should get a margin of error of 0.0452 if you round it. So now, to write the confidence interval, it's going to be the sample proportion minus the error, and the sample proportion plus the error. So 0.81 minus 0.0452, that's going to be 0.7648. So that's the minimum value. And then 0.81 plus 0.0452, that's going to give us 0.8552. So this is our 99% confidence interval. We're 99% confident that the true proportion of residents who own a car in town ABC is somewhere between 0.7648 and 0.8552. Now let's move on to part B. what sample size is needed to estimate the true proportion with a 3% margin of error at a 98% confidence level? So go ahead and try that. So we need to calculate n. Our margin of error is 3% or 0.03. Now let's begin by calculating the z-value. So let's calculate the area to the left. So it's 1 plus the confidence level of 0.98 divided by 2. So that's 1.98 divided by 2, which is 0.99. So using the z-score table, this corresponds to a z-value of 2.33. So now that we have the z-value, we could use this formula to calculate the sample size. It's going to be z squared times p hat times q hat divided by e squared. So z is 2.33, p hat is 0.81, q hat is 0.19, and the margin of error is 0.03. So you should get 928.34, but we're going to round it to 929. So that is the sample size needed if we want to construct a 98% confidence level with a 3% margin of error using these values. Number 3, a certain number of people in the state of Texas were asked if they own a house. The true proportion of homeowners was estimated to be in the range of 0.62383 and 0.67217 at a 95% confidence level. Part A. What is the value of the sample proportion? So we're given the confidence interval for the true proportion of the homeowners in the state of Texas. Using the confidence interval, how can we determine the value of the sample proportion? Feel free to pause the video and work on this example problem. Well, let's draw a picture to understand what we need to do. So let's say we have a bell-shaped curve for a typical normal distribution. And let's say this is the minimum value of our confidence interval, and this is the maximum value. The sample proportion is going to be right in the middle between the minimum and the maximum. Now, the population proportion, there's a 95% chance that it's between the minimum and the maximum. There's a 5% chance that it's outside of that. But the sample proportion will be the average of the minimum and the maximum, because that's how the confidence interval is calculated. So to calculate the sample proportion in this example, we simply need to take the sum of the minimum and the maximum and divide by 2. We just got to take the average of those two numbers, which is the same as finding the midpoint. So it's going to be 0.62383. That's the minimum of the confidence interval, plus the maximum value, which is 0.67217. And then we're going to divide that by 2. So the value of the sample proportion is 0.648. So that's it for part A. Now, part B. Calculate the error bound for the proportion. The error bound can be calculated by taking the difference of the maximum and the sample proportion. So if you were to subtract 0.67217 minus 0.648, this will give you the error bound. And that's going to be 0.02417. Another way in which you can calculate that is to realize that the error bound is going to be 1/2 of the confidence interval. And the length of the confidence interval, its range, is the difference between the maximum and the minimum value. So the error bound is going to be the range of the confidence interval, that's the difference between the maximum and the minimum value, divided by 2. So if we take 0.67217 and subtract it by 0.62383 and then divide the result by 2, that will give us the error bound. And you'll get the same answer of 0.02417. So that's it for part B. I'm just going to rewrite the value here. Now let's move on to part C. How many individuals were surveyed? How can we find the answer to that question? The number of individuals surveyed is basically the size of the sample. So we need to calculate n. The formula that we're going to use is the one we've been using before. So it's z squared times p hat times q hat divided by the square of the error. Now, we know that for a 95% confidence level, z is going to be 1.96. We covered that already. P hat, we found it to be 0.648. And Q hat is 1 minus P hat, so that's 1 minus 0.648. And we have the error, which is written below. That's 0.02417, and we're going to square this result. So I got 1499.949. So if we round that up to the nearest whole number, it's going to be about 1,500 people. So that's the number of individuals that were surveyed in this study. Now, part D. How many responded yes to the survey? So out of the 1,500 people that were surveyed, how many said yes? Well, we know that P hat is the proportion of successes. X is the actual number of successes. X would represent the absolute number of people who said yes, whereas P hat represents the proportion or the percentage of people who said yes. So if we multiply both sides by n, we could solve for x. So x equals n times P hat. So we have 1,500 people and 64.8% said yes. So we got to find 64.8% of 1,500. So it's 1,500 times 0.648, and that gives us 972. So out of the 1,500 individuals who were surveyed, 972 of those individuals said yes to the survey.